Yo! That was weird. It's Miss Baldwin, back at you with another video, trying to help you do what you gotta do for this chemistry class. Okay, this one is on bonding and naming. That's right, bonding and naming. So if you have trouble with that, let's just say you picked the right video. All right, here we go. We have two kinds of bonding. How many? Two. Not one, not three, not 4 or 5. We have 2. All right. Now, the first type of bonding, if you can see this, is ionic bonding. All right. It involves a metal and a non-metal. All right. The other type is covalent. Covalent. Yep. I made a song about it. All right. So, covalent is 2 non-metals. Now, some of y'all might be saying, Miss Baldwin, how do I know it's a metal? Well, you're going to need your periodic table to tell you that. Okay? So here it is. Now, most of the things on the periodic table are metals. That's right. So the majority of what you're looking at are metals. Everything on this whole, nope, wrong way. Everything on this whole side. You see this little line over here? That divides it. Everything over here are metals. Even down here are inner transition metals. Over to this other side, right? These are our non-metals. Okay? So let me just take a minute. If you can look and see. And I'm going to go over each column with you. This very first column right here, these are called alkali metals. All right? Everything in this column except hydrogen. Hydrogen is a non-metal. Everything in this column, alkali metals. Second column, everything in this column, beryllium's whole crew. See beryllium? All right. These are alkaline earth metals. Okay, got it? First column, alkali metals. Second column, alkaline earth. Now, this middle section, all right, these are called our transition metals. This little bottom section right here. All right, yeah, this way. They're called transition metals as well, but they're called inner transition. So let's recap. We have our alkaline metals, our alkali earth metals. Everything in the middle is transition. Even down here, we got some more inner transition. Then we come all the way over to this group, right, which is the boron group. Okay? Why is it called a boron group? Well, duh. Boron's at the top of it. Okay? All right, next to that, we have this whole little family right here. Guess what it's called? The carbon group. Why? Well, duh. Carbon is at the top. Next to the carbon group, right here, we have the nitrogen group. Okay? Next to that is the oxygen group. Now, this next to last column, well, they're kind of greedy, so they get a special name. What are they greedy for? Electrons. So, we call those our halogens. Why? Because they got to have it. All right? So, fluorine's whole group are halogens. The last group, they're special. They don't bother nobody. You know why? Because their valence shell is completely full. What do I mean by that? Well, we might talk about that in another video. They're called noble gases, all right? Because they're noble. All right, so the first column, alkali metals. Second column, alkaline earth. In the middle, what we got? Transition metals, even down the bottom, okay? Then over here, we have the boron group, carbon group, nitrogen group, oxygen group, halogens, next to the last column, and our noble gases. So, if ionic is a metal and a non-metal, it would have to be a mixture of something that's a metal and a non-metal. So let's say I take calcium and I want to combine it with chlorine. I have a metal and a non-metal. So that will be ionic. Okay? Let's say I have nitrogen and chlorine. Can y'all see it? Nitrogen and chlorine. Well, those are both non-metals. Okay? So those will be considered covalent. Got it? Two types of bonding, ionic and covalent. Ionic is a metal and a non-metal. Covalent, that's right, 2 non-metals. Now, depending upon what type of bonding, that's going to tell us how we should name it. You want to do the easy one first, or you want to do the hard one first? I'm assuming you said the easy, so we'll go the easy route. Now, we're going to start with covalent, okay? Covalent molecules are named with prefixes, okay? prefixes. Can you see it? Don't joke my handwriting. What do I mean by prefix? Well, here you go. Mono, di, tri, tetra, penta, hepta, hexa, octa, nona, deca. All right? All these things are prefixes. They go before the word. Now, mono means 1, di means 2, tri means 3, tetra means 4, penta means 5. All right? So, we will know how many atoms of each element based upon the prefix. So, on the screen, I'm going to give you some covalent molecules. Let's do P2O5, let's do PCl3, and let's do H2O. All right, these are all covalent molecules. All right. Now the first one, this is a 2. All right, so don't joke my 2. Can y'all see it? P2O5. The name of that one would be diphosphorus for 2, pentoxide. Diphosphorus pentoxide. D-I, do you spell the word phosphorus? Phosphorus. And then pentoxide. Hopefully you guys can see my writing. Diphosphorus pentoxide. Okay, the next one is PCl3. How many phosphoruses do I have in PCl3? Well, I have 1. So you would think that you could say monophosphorus, but we kind of get the gist of it. So we don't say mono if it's the first word. So the name of PCl3 would be phosphorus, trichloride. All right, phosphorus trichloride. Tri meaning 3, and we have 3 chlorines. Last one looks familiar, doesn't it? We drink it every day. At least I hope you do. H2O. Many of you would say, hey, Ms. Baldwin, that's water. Well, technically it is, but it's a covalent molecule. So the proper name for water, look at it. Tell me, what do you think? How are you going to tell me that it's 2? How are you going to tell me that it's 1 oxygen? That's right. You're going to use prefixes. So the name of water would be dihydrogen, because I have 2, monoxide. Get it? Dihydrogen monoxide. Covalent, 2 nonmetals, prefixes. Turn up! All right, now, ionic. Dun dun dun. Yeah, it's a little more difficult than covalent. Now, for ionic compounds, it depends on the type. We can have a metal and a nonmetal. We can also have a transition metal. Remember I told you about the transition metals in the middle? When we have a transition metal, okay, and we got to name it a little bit differently. And then we can also have a polyatomic, okay? Polyatomic are those things that we know: sulfate, phosphate, carbonate, acetate, all these other little things that we have. Hopefully you remember those. If not, note to self, study them. All right. Now, an example of an ionic compound would be BaCl2. Okay? It looks like Bacl2. Now, barium, holding my periodic table, is right here. It's a metal. See that? Barium's a metal. And chlorine over here. Can you see that? Chlorine is a nonmetal. So, am I going to use prefixes? No, because that's covalent. I'm just going to name it, right? It's barium chloride. That's it. So the name of this one would be Barium. And you make sure you end with IDE. You're not going to say chlorine. You're going to say chloride. Barium chloride. Again, don't joke my handwriting. I'm a work in progress. All right? We could also have something like, let's say something like FeO. Okay? Looks like FeO. Okay? Now, we have iron, which is here, and we have oxygen, which is there. Okay? Iron and oxygen, metal and nonmetal. But iron is a transition metal, so we got ourselves in a bit of a pickle. For all of the other groups, I'm going to pause for the cause. For all of the other groups, they have set charges. This column, everything in here is a +1. Everything in this column is a +2. Everything in boron's group is a +3. Carbon's group is a +4. Then we switch over to the minuses. Nitrogen is a -3. Oxygen's group is a -2, fluorine is a -1, and noble gases, they don't have a charge. Why? They're not trying to react with nobody. They already full. Okay? So if you'll notice, I skipped over the D block. Why? Because they have multiple oxidation states or multiple charges. That means they can be anything they need to be to cause a bond. Okay? That being the case, we can't just say iron oxide, because which iron is it? Is it iron that is a 2? Iron that is a 3? I don't know what charge it is. Whenever I say barium chloride, look at the first one. Barium is always going to be a 2, and chlorine is always going to be a 1. So barium is the same person. But iron, they're one of those friends that kind of change up on you. Depending upon the day, they cool with you. The next day, they might not be. So we need to specify what kind of day it is. We need to specify what kind of iron this is. So, of course, we're going to put iron. Of course, we're going to put oxide. But in the middle of the two words, we're going to need, a parentheses. Now, what this parentheses will do is tell us what iron it is, what charge of iron it is. Now, Ms. Baldwin, how I'm going to tell you what charge iron is when I'm looking at this periodic table and I don't know it. The only charges I have are for these other little groups that you gave me, Ms. Baldwin, but you didn't give me charges for these ones in the middle. So what am I going to do? You trying to set me up? No, I'm not. You look at what it's connected to. Iron, in this example, is connected to 1 oxygen. Now, we may not know much about iron, but we do know about oxygen. What charge does this group form? That's right. Hopefully you said it. It's a -2. So if oxygen forms a -2 charge, what has to be the charge on iron to cancel out a -2? Are you thinking about it? Did you already answer out loud? Hopefully you did. It is a +2. +2 cancels out a -2. So in our parentheses, we're going to put Roman numeral 2. So this is iron 2 oxide. Now let's just say we had another kind of compound. I'm going to show you how the iron switches it up. Let's say we had Fe. Look at this top one. Fe2O. All right? This is a whole different formula than FeO. You see it? FeO, then you got Fe2O. Well, Fe2O is still going to be iron and oxide. So I'm going to write that iron, and then I'm going to have oxide. But I'm going to have to leave a space for the charge it's going to be. All right? Now, I have 2 irons. See that? 2 irons with 1 oxygen. Now, I don't know nothing about iron because it's a transition metal. But I do know that oxygen is a -2. Now, what's going to cancel out with a -2? A +2. But that +2 has to be divvied up between those 2 irons. So if I need to get a total of a +2 between 2 irons, how much does each one have to be? Are you thinking? I have to get a total of +2 between 2 people. Each person is going to have to give me 1. Okay? So the charge of iron in this scenario is iron 1. See that Roman numeral 1? Oxide. Okay? So see, when you have a transition metal, all you have to do is specify with Roman numerals and parentheses. All right? So here's our recap. Covalent, prefixes, 2 nonmetals. All right? If you see 2 nonmetals, you name it using the prefixes. Ionic is a metal and a nonmetal. It's easy to name. You name the first one, and you name the last word ending in IDE. All right? The only time you'll have a challenge is if what? If it is a transition metal. A transition metal means something in the middle or something down here, right? One of these last two. Can y'all see? Anytime you have something right here and something down here, that's when you may have a challenge, right? And then you would have to specify using parentheses, all right, and Roman numeral, what the charge of the transition metal is. This has been Bonding and Naming, and I have enjoyed this time with you. Please stop watching now.